Hello students, today we will be solving Pure Maths Paper 1, Variant 2 from May-Jun 2016. Question number 1. Functions f and g are defined by fx is 10 minus 3x, x is an element of all real values, and gx is 10 over 3 minus 2x, x is an element of all real values and x does not equal to 3 over 2. We need to solve the equation f of x is equals to gf2. So let's first find this and then we will find this and then we will equate them. So f of x means basically we need to substitute this equation into x. So it will be 10 minus 3 again 10 minus 3x. So we are substituting 10 minus 3x into x. So that gives us 10 minus 30 plus 9x. Simplifying this we get 9x minus 20. For g of x we need to substitute this 10 minus 3x into this equation. So it will be 10 over 3 minus 2 times 10 minus 3x. That gives us 10 over 3 minus 20 plus 6x. Simplifying this we get 10 over 6x minus 17. Now when we use the value 2 for x, we get 10 over 6 times 2 minus 17. That gives us negative 2. Now let's equate them. So for this we got 9x minus 20. So 9x minus 20 must be equal to negative 2. Therefore 9x is equals to 18. So x must be 2. Question number 2. A curve is such that dy by dx is equals to 8 over 5 minus 2x square. Given that the curve passes through 2, 7, find the equation of the curve. So we are provided with dy by dx. That means we need to integrate this equation to find the equation of the curve. So for integrating, what we can do, we can take away the constant outside and it will be 8 integration of 5 minus 2x to the power negative 2 dx. Now power is the operator. So the box is this. So we need to differentiate this, and differentiating this we get negative 2. Now let's balance the equation. So it will be 1 over negative 2. So then we simplify this and this becomes negative 4, and now we can integrate the operator. So that will be negative 1 and in the denominator will be negative 1, and the integral sign, the differentiation of the box and dx will go away. So we are left with y is equals to 4 over 5 minus 2x plus c. This double negative makes it positive and we can bring this to the denominator, making it a power of a positive 1. Now, since we are provided with the 0.27, that means we can use this to find the constant c. So at 27, we simply substitute these values. So 7 is equals to 4 over 5 minus 4 plus c. With the help of that, we get the value of c, which is 3. That means the equation of the curve must be y is equals to 4 over 5 minus 2x plus 3. Question number 3 is related to vectors, which is not in the syllabus at the moment. Question number 4. Find the term that is independent of x in the expansion of x minus 2 over x to the power 6. So independent of x means x to the power 0. There will be no x term. So for that, first let's use the formula. So that will be 6cr x to the power 6 minus r times negative 2 over x to the power r. Now in order to find the value of r for which we will be getting the independent of x, we need to isolate the x terms. So this will be x to the power 6 minus r. So I'm just isolating the x terms only. I'm not bothered about 6cr or negative 2. So x to the power 6 minus r times x to the power, so this is in the denominator. So we can write it as x to the power negative r. This must be equal to x to the power 0, which defines the independent of x. the term that is independent of x. So since there is multiplication, that means we need to add these two power. So this will be x to the power 6 minus r plus minus r, which is minus r, equals to x to the power 0. That becomes x to the power 6 minus 2r is equals to x to the power 0. With the help of equality rule, we can say 6 minus 2r is equals to 0. Therefore, 2r is equals to 6. That means r equals to 3. So we must use this value of r so that we can get the term which is independent of x. So 6c3 times x to the power 3 minus 2 over x to the power 3 gives us 20 times x cube times negative 2 cube is negative 8 and x cube is x cube. So these two cancel out and it becomes minus 160, which is independent of x. In the second part of the question, they have given us 2 plus 3 over x square and x minus 2 over x to the power 6. And again, the main question was to find the term independent of x. So for this is of 4 marks. This is of 4 marks. So we need to do a bit of working. So previously we found that when r is equals to 3, only for this expansion, we are getting the term independent of x. Now you can see that when we are trying to multiply 2 plus 3 over x square with this expansion, the only time we will be getting the term independent of x is when we are multiplying 2 with the term which was independent of x for this expansion. Now we also need to multiply 3 over x square with something from this expansion, which will also be giving us independent term of x. So if x square is in the denominator, that means from this expansion we need something which will have x square in the numerator. So for that we need to figure out again what should be the value of r that will give us the term which has a coefficient of x square. So again 6cr x to the power 6 minus r negative 2 over x to the power r. I'm using only this bit to figure out which term, which value has x square. So again, let's isolate the term, isolate the x only from this formula. So it will be x to the power 6 minus r times x to the power minus r equals to, now it's not x to the power 0, we need x square. So again it will be x to the power 6 minus r, that becomes x to the power 6 minus 2r. So 6 minus 2r is equals to 2. Therefore 2r is equals to 4. That means r must be 2. So we can say that 6c2 x to the power 4 minus 2 over x square will eventually be giving us the term which has x square. So this will be 15 times x to the power 4 times 4 over x square. That gives us 60x square. So now what we can do is multiply 2 with the term which is independent of x. They both don't have x next to it, so we can simply use this from the first part of our answer. So 2 times negative 160 gives negative 320, and with 3 over x square we need to multiply the term 60x square, and eventually these two will cancel out and we will be getting 180, which is independent of x. So now we need to sum these two numbers. So it will be negative 320 plus 180, which is negative 140. Question number 5. In the diagram, the triangle ABC is a right angled at C, and M is the midpoint of BC. So this is right angle at C and M is the midpoint of BC. That's why if this is X, this is also X. That means BM is equals to MC. It is given that angle ABC is pi by 3. So this is pi by 3. And angle BAM, this one is theta. And it's in radians, of course. Denoting the lengths of BM and MC. We need to, denoting the lengths BM and MC by X. Okay, so we need to find AM in terms of X. We need to find AM, this line. So for this, what we can do, let's consider the triangle ABC first. And with the help of that, we can use SOHCAHTOA. So 10 pi over 3 must be AC by BC, opposite by adjacent. So 10 pi by 3, which is 1060, and we know that 1060 is root 3. So this will be equal to AC, which we don't know, over BC is x plus x, which is 2x. That means AC must be 2 root 3x. And in triangle AMC, now we are considering this triangle AMC. AMC. We can use the Pythagoras formula. So AM square, which is the hypotenuse, must be equal to AC square plus MC square. So AC, this is what we found. So it will be 2 root 3x whole square plus MC is x. So it will be x square. So that gives us 2 square is 4, and 4 into this will be just 3. 4 3 is a 12. 12x square plus x square, which is 13x square. That means AM is equals to x root 13. And this will be the final answer because they have told us to find AM in terms of x. In the next part of the question, show that theta is pi by 6 minus tan inverse 1 by 2 root 3. Let's again consider the triangle AMC. So this is the triangle we are considering right now, AMC, and tan MAC. That means I'm talking about this angle. Tan MAC must be opposite by adjacent. So MC over AC. MC over AC. MC is x, and we found AC previously. So AC will be 2 root 3x. So MAC, angle MAC is tan inverse of 1 over 2 root 3. X and x will cancel out. And BAC, angle BAC, which is this, the whole thing, angle BAC. BAC must be pi by 2 minus pi by 3. Okay, so what happened here is, if this is 90, think of the whole triangle. If this is 90, that means these two angles, the angle ABC and angle BAC, must add up to 90 so that the whole triangle becomes 180. So this means this angle must be 90 minus this angle, because together they sum up to 90. So therefore 90 means pi by 2 minus pi by 3, which gives us pi by 6. So pi by 6 is this angle, this whole angle, pi by 6. Okay, so MAC is pi by 6 minus theta, and theta must be equal to pi by 6 minus MAC. Therefore, we already found that MAC is tan inverse of 1 by 2 root 3. So we can say theta is equals to pi by 6, or 1 by 6 times pi minus tan inverse of 1 by 2 root 3. Question number 6. The diagram shows a circle with radius r centimeter and center O. The line PT is the tangent to the circle at P, and angle POT equals to alpha radians. The line OT meets the circle at Q. Express the perimeter of the shaded region PQT in terms of R and alpha. So this is the shaded region. So we need to find the perimeter of the shaded region only. That means we will be needing this arc length PQ, this straight line PT, and the straight line QT. This question consists of 3 marks. So arc length is the easier one. Arc length PQ must be r theta, and that's the formula. Arc length is r theta. So over here, the radius is r, and the theta, which is the angle, is alpha. So it will be r alpha. In triangle OPT, tan alpha tan alpha is opposite by adjacent. So it will be PT over OP. So PT is equal to OP tan alpha. So PT must be R tan alpha because OP is R. Then we know that radius and tangent meet at 90 degree. So this must be a right angle triangle, the triangle OPT. So we can use the Pythagoras formula to find OT. So OT square is equals to OP square plus PT square, and OP is R, so R square, and PT is R tan alpha, which we found earlier. So it will be R tan alpha whole square. That gives us R square plus R square tan square alpha. So OT square is equals to, we can take R square common and it will be 1 plus tan square alpha. So OT square is equals to R square, and 1 plus tan square can be written as sec square alpha. So if I square root, we get OT is equals to R sec alpha. So you must know the manipulation of this, otherwise you won't be able to square root it easily. So it will be R square sec square alpha. After square rooting becomes R sec alpha. Now we just need this bit QT. So we found OT. That means we can take away the radius R from OT and we will be left with QT. So QT is equals to OT minus OQ. So QT is equals to R sec alpha minus R, which is the radius. So QT is equals to R within brackets sec alpha minus 1. So the required perimeter, which is R alpha, which was the arc length, plus R tan alpha plus R sec minus 1. We can take R common and make this sec alpha minus 1. So from this, we can again take R common and this becomes alpha plus tan alpha plus sec alpha minus 1. In the next part of the question, in the case where alpha is equals to pi by 3 and R equals to 10, find the area of the shaded region correct to two significant figures. So PT is equals to R tan alpha, and we are provided with R, which is 10, and alpha is pi by 3. So we can write it as 10 tan pi by 3, which means 10 pi by 3 is root 3. So it will be 10 times root 3, which is 10 root 3. And area of triangle OPT. So my objective is to find the triangle OPT and take away the sector, and then I will be left with the shaded region. So area of triangle OPT is half times base times height. Base is PT and the height is R. So R is 10. So that gives us 50 root 3. Now for the area of the sector OPQ, half times, that the formula that we are using now is half R square theta. So R is 10, so that will be 10 square, and theta is pi by 3. So that gives us 50 pi by 3. And the required area must be then triangle minus the sector, which gives us 34. Question number 7. We need to prove the identity 1 plus cos theta over 1 minus cos theta minus 1 minus cos theta over 1 plus cos theta is identical to 4 over sin theta tan theta. So taking the left hand side, which is this, I can say that 1, after doing LCM, let's do the LCM first. So 1 minus cos theta, 1 plus cos theta in the denominator, and we have 1 plus cos theta times, since we don't have this in the denominator, that means we need to multiply this with 1 plus cos theta. So similarly, we have 1 plus cos theta in the denominator, we don't have 1 minus cos theta. That means we need to multiply 1 minus cos theta with this. So we can see that there are two of 1 plus cos theta. So it will be 1 plus cos theta whole square minus 1 minus cos theta whole square. And in the denominator, we can see there is a similarity with the formula a minus b whole square. So this is not a minus b whole square. It will be a minus b and a plus b. That gives us a square minus b square. So 1 minus cos theta and 1 plus cos theta can be written as 1 square minus cos square theta. Now, if the formula that we have used to understand that 1 minus cos theta and 1 plus cos theta can be written as 1 square minus cos square theta. So the formula was what? A square minus b square is a minus b, a plus b. Similarly, if you look closely, we have in the numerator, we have something square minus something square. So this can also be written as, let's consider this, the whole thing to be a and this whole thing to be b. So this is a square minus b square. So it will be a plus b. That means 1 plus cos theta plus 1 minus cos theta. And it will be a times a minus b. So this will be 1 plus cos theta minus 1 minus cos theta. So both the numerator and denominator, I'm using the formula a square minus b square, which is a plus b, a minus b. So if I expand the brackets, it will be 1 plus cos theta plus 1 minus cos theta, and this will be 1 plus cos theta minus 1 plus cos theta. Within the brackets, these will cancel out. So we are left with 1 plus 1, which is 2, and this one will be cos theta plus cos theta, which is 2 cos theta, over sine squared theta, which gives us 4 cos theta over sine squared theta, or we can say 4 cos theta over sine squared theta can be written as sine theta, and cos theta by sine theta, we can write it as, we can write cos theta by sine theta as 4 cot theta. But since we are trying to write it in the denominator, it will be 4 over tan theta sine theta. So cos theta by sine theta is tan theta in the denominator. So which is the same as 4 over sine theta tan theta, which is equal to the right hand side. In the next part of the question, it says hence solve. For theta lies between 0 and 360, the equation sine theta times what we had earlier equals to 3. We have already proved that this bunch means 4 over sine theta tan theta. So sine theta times this is equals to 3. Or we can say these sine theta and sine theta will cancel out, and we are left with 4 over tan theta equals to 3. That means tan theta is equals to 4 over 3. So let's find the basic angle first. So alpha is equals to tan inverse 4 over 3. That gives us alpha is equals to 53.13. And we are taking it in degrees because our limit is in degrees. And what we can do now, since theta lies between 0 and 360, so we know that positive 10, the 10 is positive right now, positive 10 lies in the first and the fourth quadrant. So, and we will be taking both of them since both of them lies within 360. So the first angle, which is the basic angle, is also the actual angle, and the other angle will be 180 plus the basic angle, which is 233.1. Question number 8. 3 points have coordinates 0, 7, 8, 3 and C 3, K, K. Find the value of the constant K for which C lies on the line that passes through A and B. So for this one, we need to find the value of the constant K for which C lies on the line that passes through AB. So let's first find the equation of the line. And since we have 2 points, like both of the points are known for A and B, we can use the formula y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1 to get the answer easily. We simply need to substitute these coordinates into the formula. So y minus 7 over 3 minus 7 equals to x minus 0 over 8 minus 0. So that gives us y minus 7 over negative 4 equals to x over 8. So y minus 7 over negative 1 equals to x over 2. I'm simplifying the denominator. As I can see, these are multiples of 4. So 2y minus 14 equals to negative x. So 2y plus x equals to 14. This is the equation of the line AB. Now, since C, the point C lies on the line AB, we can say that this must satisfy the equation. So we can simply substitute this coordinate into the equation, which means 2 times k plus 3k is equals to 14. That gives us 5k equals to 14. Therefore, k is 14 over 5. So k will be 2.8. In the next part of the question, now the condition has changed. It says that C lies on the perpendicular bisector of AB. So first we need to find the equation of the perpendicular bisector. So for that, we will be needing the midpoint of AB because that is the point through which the perpendicular bisector will be going through. So the midpoint of AB will be, the formula that I'm using is x1 plus x2 over 2, comma, y1 plus y2 over 2. So the points of AB is being used here. So 0 plus 8 over 2 and 7 plus 3 over 2, that gives us 4 and 5. And equation of the line AB was 2y plus x equals to 14. This was the equation of the line AB which we found earlier. So 2y is equals to minus x plus 14. That means y is equals to negative half x plus 7. The reason why we have done this is to figure out the gradient of the line for AB. We have converted this, we have manipulated or rearranged the whole equation into the format of y equals to mx plus c, where m is telling us the gradient of the line. So this is y equals to mx plus c, where m is negative half. That means gradient of the perpendicular bisector must be negative reciprocal of this. So that gives us 2. So now we have the point through which the perpendicular bisector is going through and the gradient of the line as well, gradient of the perpendicular bisector. So equation of the perpendicular bisector must be y minus y1 equals to mx minus x1. So the points are 5 and 4 and the gradient is 2. So it will be y minus 5 equals to 2 times x minus 4. That gives us y minus 5 equals to 2x minus 8. So y is equals to 2x minus 3. Now, since C point lies on the perpendicular bisector, so this point must be satisfying the equation. So we simply substitute this coordinate into this equation again. So k is equals to 2k, 2 times 3k minus 3. That gives us k is equals to 6k minus 3. So negative 5k equals to negative 3. So k must be 0.6. Question number 9. A water tank holds 2000 liters when full. A small hole in the base is gradually getting bigger so that each day a greater amount of water is lost. On the first day after filling, 10 liters of water are lost and this increases by 2 liters each day. How many liters will be lost on the 30th day after filling? So the first day, this is we need to understand that this is an arithmetic progression because 10 liters of water are lost and this increases by 2 liters each day, which means that the first day is 10 liters, then it is 12 liters, then it is 14 liters, then it is 16 liters. So that means it itself is an arithmetic progression. So the first term is 10, the common difference is 2. And for the 30th day, we need to find the 30th term. So that will be a plus n minus 1 times t. That is 10 plus 30 minus 1 times 2. That gives us 68. So 68 liters will be lost on the 30th day after filling. In the next part of the question, the tank becomes empty during the nth day after filling. Find the value of n. So if it becomes empty, that means 2000 liters, uh, which was in it initially when it was. So since we are losing all of it, that means we need to find the value of n, the sum of n terms, so that we can figure out when this whole amount is lost. So we know the sum of n terms formula is n over 2 times 2a plus n minus 1 times d, and a is 10 and d is 2. Simplifying this, we get 2 times 2000 is 4000, and this will become 20 plus 2n minus 2, or we can say n times 2n plus 18 equals to 4000, or we can say 2n squared plus 18n minus 4000 equals to 0. Now we can simplify this further by dividing both sides by 2. That gives us n squared plus 9n minus 2000 equals to 0. Now n is equals to, with the help of quadratic formula, we can say minus b plus minus square root of b square minus 4ac over 2a, and where a is 9, sorry, a is 1, b is 9, and c is minus 2000. That gives us negative 9 plus minus square root of 9 square minus 4 times 1 times 2000 over 2 times 1. So n is 40.4 and n is negative 49.4. But n cannot be negative because it tells us about the number of terms. And n is also an integer. So 40.4 will not be acceptable in this case. So we need to find the nth day, and day is a integer number. So since it's more than 40, I'm not rounding it up. As you can say 40.4, if I try to do it in two significant figure, it will be just 40, but it's not about correcting it to two significant figures. It's the nth day they're talking about, and it is an integer. So if it's more than 40 days, that means it's the 41st day where the tank will become completely empty. In the next part of the question, assume instead that 10 liters of water are lost on the first day, and that the amount of water lost increases by 10%. So this gives us the hint of geometric progression. On each succeeding day, find what percentage of the original 2000 liters is left in the tank at the end of the 30th day after filling. So now the first term is 10, and since it increases by 10%, that means 100% plus 10% is 110%. That means in decimals it will be 1.1, and the term that they're talking about is 30. So n is 30, and we know that since r is greater than 1, we will be using the formula for sum of 30 terms will be a times r to the power n minus 1, because r is greater than 1. So 10 times 1.1 to the power 30 negative minus 1 over 1.1 minus 1, that gives us 1644.9, or we can say 1645. So the required percentage, they're asking us find what percentage of the original 2000 liters is left in the tank at the end of the 30th day after filling. What is left? What is the percentage that is left? So that this was the amount that we had initially minus this is what is gone over what we had initially times 100. That gives us 17.75. So this is the amount, this is the percentage which is left in the tank at the end of the 30th day. Question number 10. The diagram shows part of the curve y equals to 8 over x plus 2x for x is greater than 0, and the minimum point m. Find expressions for dy over dx and d square y over dx square and the integration of y square dx. This question consists of 5 marks. So let's first find this. So we can write this equation as y is equals to 8x to the power minus 1 plus 2x. Differentiating this, it will be minus 1, which is negative 2, and minus 1 times 8 is negative 8. So it will be minus 8 times x to the power negative 2, and 2x will become just 2. Now for the second derivative, we need to differentiate this equation again. So negative 2 times negative 8 is positive 16. Negative 2 minus 1 is negative 3. So 16x to the power negative 3, and this will become 0. Now, before we integrate y square, we need to find what y square is. So y is 8 over x plus 2x. So y square must be, we are using the formula a plus b whole square. That gives us 64 over x square plus 32 plus 4x square. Now integrating this, so this one, 64 by x square is basically 64x to the power minus 2. So minus 2 plus 1 is negative 1, and negative 1 times negative 1, 64 over negative 1 is negative 64, and 32 will become 32x, and 4x squared, this one will be 2 plus 1 is 3, and 3 will come to the new denominator. So it will be 4 over 3 times x to the power 3 plus c. We have to use this c because they have asked us to find the expression. That's it. In the second part of the question, we need to find the coordinates of M and determine the coordinates and nature of the stationary point on the part of the curve for which x is less than 0. So at M, dy by dx is 0. So we need to find the coordinates of M, and we can clearly see in the diagram that M is the stationary point, and it's already given that it's the minimum point. So that means at minimum point, dy by dx is equals to 0. So minus 8 over x square plus 2 is equals to 0. This was dy by dx, which we found earlier. So if we do LCM, this will become minus 8 plus 2x square, and x square times 0 is 0. So 2x square is positive 8, x is equals to plus minus 2. So x square equals 2x square equals to 8. That means x square will be 8 over 2, which is 4. And if we square root, it becomes plus minus 2. So for M, x is equals to 2. And now we need to substitute this value of x into the equation of the curve, which was y is equals to 8 over x plus 2x. That means 8 over 2 plus 2 times 2. That gives us y equals to 8. That means the coordinate of M is 2 and 8. Moving on, remember that we got two values of x, positive and negative, and we chose positive 2 to find the value of M, because we can clearly see in the graph that the point M is in the positive x-axis. That means we should be taking the positive x value to consider the value of the coordinate of M. For the negative part, which is x equals to negative 2, you can see in the remaining part of the question, after they asked us to find the coordinates of M, they're telling us, and determine the coordinates and the nature of the stationary point on the part of the curve for which x is less than 0. That means we need to figure out what will happen when x is negative 2. So when x is negative 2, if we again substitute this value into the equation of the curve, we get y is equals to 8 over negative 2 plus 2 times negative 2. That gives us y equals to negative 8. And that is the other coordinate which is not in the diagram. That is also a point, a stationary point, because for both positive and negative 2, the dy by dx is 0. So x is negative 2. Now let's put it to test to figure out what kind of stationary point it is, whether it is a maximum or a minimum. So substituting x equals to negative 2 into the second derivative, which is 16 over negative 2 cube, gives us negative 2. Since for x -2 we are getting a value which is less than 0, that means the point -2 and -8 is a maximum point. This will be a maximum point. In the third part, we need to find the volume obtained when the region bounded by the curve, the x-axis, and the lines x equals to 1 and x equals to 2 is rotated 360 degree about the x-axis. So this was the graph, and I'm considering this line to be x equals to 2 because the coordinate of m was 2. The x coordinate of m was 2, and therefore x equals to 1 must be before 2. And this will be rotated 360 degree about the x-axis. So we need to find the volume. So we need to find the volume of this region. Okay. So we found y square, integration y square previously, which was this. And in order to find the volume, the limits will be 2 and 1. So we simply need to substitute to this the value 2 and 1 into this equation. That way we will be getting this, and simplifying this we get 128 over 3 plus 92 by 3. By the way, in order to find the volume you need to use this formula, which is pi integration y squared dx if the volume is getting rotated 360 degree about the x-axis. So this will be 220 pi over 3, which is close to 230. Question number 11. The function is defined by fx is 6x minus x square minus 5 for x is an element of all real values. Find the set of values of x for which fx is less or equal to 3. So this was the equation. Now this is less or equal to 3. So we can say 6x minus x square minus 8, because minus 5, and if you bring 3 to the left hand side it becomes negative. So minus 5 minus 3 is negative 8. And we can rearrange this and write it as minus x square plus 6x minus 8 less or equal to 0. And we can also multiply both sides by -1. Then we get x square minus 6x plus 8. And since we have multiplied both sides by -1, the inequality sign will flip. It will become greater or equal to 0. Then we can do middle term break. So it will be x square minus 4x minus 2x plus 8. Then we can take x common, and we will have x minus 4, and if we take minus 2 common, we again have x minus 4. So the factors are x minus 2 and x minus 4 is greater than 0. Now let's find the critical values. That will be x is 2 and x is 4. Now let's put this 2 in the number line. So 2 and 4, and since it's a positive quadratic equation, we have to take the U shape, and for the inequality greater than 0, x must be less than 2 and x must be greater than 4. So these are the set of values of x for which fx is less or equal to 3. In the next part of the question, given that y equals to mx plus c is a tangent to the curve y equals to fx, show that 4c equals to m square minus 12m plus 16. So this is the equation of the curve, and this is the equation of the tangent. So we can understand that we need to use the formula of discriminant, because tangent and curve, when they're meeting at one point, and therefore the discriminant must be equal to 0. So let's equate them first because they will be meeting. So 6x minus x square minus 5 equals to mx plus c. So if I bring everything to the left hand side, this becomes 6x minus x square minus 5 minus mx minus c equals to 0. Or we can say, rewrite it as minus x square plus, if I take the coefficients of x together, it will be 6 minus m within brackets, then x plus minus 5 minus c equals to 0. Now, when it is a tangent, with the help of this, we will be showing that 4c is equals to this. So b square minus 4ac is equal to 0. So a is minus 1, b is 6 minus m, and c is minus 5 minus c. I'm comparing this equation with the quadratic equation ax squared plus bx plus c. So we need to expand this with the formula a minus b whole square. That gives us 36 minus 12m plus m square. And this will become negative 20, negative 4c. We can rewrite it as m square minus 12m plus 16 minus 4c equals to 0. Therefore, 4c is equals to m square minus 12m plus 16. In the next part of the question, the function g is defined as g is 6x minus x square minus 5 for x is greater or equal to k, where k is a constant. Express 6x minus x square minus 5 in the form of this. So this is the format of a completing square. So let's consider y is gx. So y is equals to 6x minus x square minus 5. Or we can rewrite it as y is equals to minus x square plus 6x minus 5. Then before we do completing square, we need to take minus common, and this becomes x square minus 6x minus 5. So this is the bit for which I'll be doing the completing square only. So minus remains outside, we use another bracket. So this will be x, this minus, and 6 over 2 is 3. So this will be whole square minus 3 whole square. And then we can expand the brackets, expand this outside bracket. So it will be minus x minus 3 whole square, and this is minus 9. So my double negative will make this positive. So it will be positive 9 minus 5, which gives us y is equals to minus x minus 3 whole square plus 4. But since they have asked us to express it in this format, it will be 4 minus x minus 3 whole square. In the next part of the question, it says state the smallest value of k for which g has an inverse. Always remember, for such questions, we need to find the turning point, and we know that the completing square tells us the turning point. So the function was minus x minus 3 whole square plus 4, from which we can understand the turning point must be positive 3 and 4. Since this is negative, x will be positive and y will remain the way it is. And x is greater or equal to k. That was given in the question. That means for the inverse to happen, currently this is a quadratic equation, and we know that quadratic equation is a many to one function, and inverse only exists for one to one function. So if I take away the left part of the curve, left side of the curve from the turning point, then I'm left with the right side of the curve, which is, that must be x is greater or equal to 3. X is greater or equal to 3. That means the value of k is equal to 3. In the next part of the question, for this value of k, find an expression for g inverse of x. So now let's consider y is gx. So y will be 4 minus x minus 3 whole square. So x minus 3 whole square equals to 4 minus y. So x minus 3 is plus minus square root of 4 minus y. So x will be 3 plus minus square root of 4 minus y. Since y is equals to gx, so g inverse of y must be x. So g inverse of y must be, we can just substitute this x over here. So it will be 3 plus minus square root of 4 minus y. Therefore, g inverse of x must be equal to 3 plus minus square root of 4 minus x. Now, since we know that x is greater or equal to 3, that means we should not be taking the negative because it will lower the value. So we need to go above 3. So g inverse of x will be 3 plus square root of 4 minus x. And that will be all for now. I will see you in the next video.